السلام عليكم ورحمة الله وبركاته. Final revision for paper 4 Igcse Chemistry 0620-0971. Now for paper 4 tomorrow, we're planning to revise the whole chapters, 14 lessons, and we have to know what are the examiners seeking for in your answers. You have to be aware of the lesson objectives for each chapter and to learn exactly the mistakes you should avoid during answering the papers, and the avoidance of mark loss is your aim. Do not be so keen on answering question by question. Just collect as much correct marks as you can. So if you have, or if you face, or you come through any question that you feel you don't really know its answer, just put a circle around it and skip it immediately. Now, tomorrow's paper is out of 80 marks. You have to make sure that you collect as much marks as you can during solving this paper. Do not forget the fact that the symbols of chemicals should start with a capital letter, end with a smaller one. So if you write the symbol for chlorine, it should appear in this way. If you write the symbol for zinc, it should be like this. For calcium, like that. What is the correct? These are the correct symbols. What are the incorrect ones? Some of you write the chlorine in this form. Now this is wrong. Zinc, again wrong. Calcium, again wrong. You should put the first letter as a capital one, as large as you can, and the smaller one should appear small. Tamam? Now, starting with chapter 1, which is the states of matter, the most important points that you should keep in mind are the exothermic and endothermic physical changes a matter undergoes. Now, the exothermic ones are those that occur by cooling. What are they? Condensation, freezing, and deposition. Now, deposition is the change of a substance from the gaseous state to the solid state by cooling. That's sometimes described as sublimation, but we name it as deposition, or we describe it as deposition because it's a change from a gas to a solid. It's deposited. Okay, I won't be able to answer any phone calls right now. So again, deposition is the change of matter from the gaseous state to the solid state during sublimation. So it's opposite to the sublimation from a solid to a gas. And it happens by cooling. السلام عليكم ورحمة الله وبركاته. جيهان، أنا في بعمل التسجيل بتاع الفاينل ريفيجن، هينزل فأرجع مرة تانية وأكد إنه deposition is the change of substance from the gaseous state to the solid state by cooling. Now, what about endothermic changes? Endothermic changes are those changes that occur by heating, like the melting, evaporation, boiling, and sublimation from a solid to a gas. You see? So the exothermic energy, the exothermic physical changes are those that occur by cooling, and these are condensation, freezing, deposition, and the endothermic ones are those happening by heating, like melting, evaporation, boiling, sublimation. And sublimation here, I mean the change of matter from the solid state to the gaseous state, and this occurs by heating. Now, proceeding to the heating and cooling curves of matters. Now, I want you to describe this for me. Is this a heating curve or a cooling curve?
Cooling curve.
Yeah, it's a cooling curve. Now, we start usually cooling curves with a gas, but not usually. Sometimes he starts with the liquids. You have to be aware of the changes that you observe in the curve. Now we have two changes of state, which is from a gas to a liquid and then from a liquid to a solid. So that's a full cooling curve. Now during this full cooling curve, if I ask you to describe the area from A to B with an equation, you will say that this is condensation. In condensation, the substance X will change from the gaseous state to the liquid state. And you will represent it by this equation. Now on the y-axis, you will place temperature. On the x-axis, you have the time measured in minutes. Now, if I ask you to represent the change of state from D to E, this area, how would you write its equation? Do you know how to write the equation for the area D to E? It will be X from which state to which state?
Liquid to solid.
Yeah, exactly, liquid to solid. Thank you so much. So, heating curve can come طبعا from the curve. You can determine the boiling point of the substance, which is equivalent to its condensation point, and the freezing point, which is equivalent to the melting point. Again, condensation point is equivalent to the boiling point, and the melting point is equivalent to the freezing point. Now, the third part of this chapter is the diffusion. Now, factors affecting rate of diffusion are the four factors: spaces between particles, mass, temperature, and presence or absence of other particles. Now, which one of these factors is the main factor that affects rate of diffusion? It's the mass. Because if you are having a particle diffusing at a high temperature and another one which is heavier diffusing at the same high temperature, still the lighter one diffuses at a higher rate than the heavier one. So the diffusion has a main factor affecting its rate, which is the mass. Mass, again, why mass is the main factor? Because even at high temperature, still lighter particles diffuse faster than heavier ones. طبعا, when spaces between particles are larger, then diffusion happens at a faster rate. If temperature is higher, diffusion happens at a faster rate. And in absence of other particles, like in space, diffusion is much faster than in air. In space, diffusion is faster than air because of absence of molecules of gases. The last part of this chapter is the states of matter according to their melting and boiling point compared to a given temperature. So if we have a substance which is solid at 60, then to exist as a gas, its melting and boiling point should be both lower than 60. To exist as a solid, its melting and boiling point should be more than 60, and if it exists as a liquid, its melting point should be lower than 60, boiling point higher than 60. I will put this in brief description here on the board. For a substance to exist as a solid, its melting point and boiling point should both be higher than a given temperature. To exist as a liquid, its melting point should be lower than the given temperature, boiling point higher. To exist as a gas, both melting and boiling points should be below that given temperature. Now, bye-bye chapter 1, going to chapter 2. Now, chapter 2 is the experimental techniques and separation methods. I should be aware of all lab apparatus and the uses of these tools. طبعا, the most accurate lab apparatus that we have in the lab are the burette and the pipette, and we should be aware in the condensation, in the condenser. During condensation, we enter cold water from below and we allow it to leave the condenser from above. In this chapter, we have to be aware of the definition of the term solubility. Solubility means the amount of substance measured in grams in 100 grams of water. Again, we have to define the term solubility as the amount of substance in grams that can dissolve in 100 grams of water. And this amount is different according to the chemical we are dissolving. Some chemicals have high solubility and some of them have low solubility depending on the type and the nature of that chemical. In this chapter, we have to discuss the separation methods that we should classify according to the mixtures that we are separating. If we have a solid-solid mixture, then we can separate it by different methods. One of them is the magnetic method. The other way is the sublimation method. And the last one is the solvent extraction method. Now, magnetic separation is done for substances that, or for mixtures that contain magnetic substances like iron, cobalt, or nickel. If we have any of these metals mixed with another non-magnetic substance like glass or plastic, then we approach a magnet to separate the magnetic one. For the sublimation method, if we have a sublimable material mixed with a non-sublimable one, sublimable chemicals that we have in the syllabus are iodine crystals, the solid dry carbon dioxide gas, which is the dry ice, the ammonium chloride, the ammonium carbonate, iron 3 chloride, and aluminum chloride. These are all sublimable materials. If any one of them is mixed with another one which is non-sublimable like sulfur or sodium chloride, then I can separate the sublimable one by heating and then by deposition. So I heat the mixture and put a cold surface above like an inverted cold funnel so that the gaseous substance will deposit on that cold surface after it sublimes from the mixture. The solvent extraction method is done when we have two solids, one of them soluble in a solvent and the other is not, like in case of iodine, which dissolves easily in ethanol but is insoluble in water. And I can separate it easily by adding ethanol to the solid mixture to dissolve iodine and leave the other substance undissolved like sodium chloride. And then we take the filtrate after filtration. We take the filtrate and we heat it in a water bath because the alcohols are so flammable, and we obtain crystals of iodine by crystallization. For liquid-liquid mixtures, we can apply either simple distillation or fractional distillation. Now, the difference between them is that simple distillation will separate two liquids from each other, but fractional distillation can separate a large number of liquids by difference in boiling point. In simple distillation, the lower boiling point liquid will evaporate first and will get collected after condensation. In the fractional distillation, the same concept. The lower boiling point liquid evaporates first and get collected, then followed by the lower and the higher, and the higher. And make sure that you don't change the temperature or the adjustment of the heater you are using, because the thermometer by itself will have a higher reading once the first liquid is totally collected. The reading on the thermometer will get higher by itself, showing that the second liquid with the higher boiling point is being evaporated and collected right now, so that we can change the collecting apparatus and get a new one which is clean to collect the other liquid, and so on. So if we have three liquids which have the three boiling points, for example, 110, 135, and 98, then the first liquid to evaporate will be the one with the boiling point 98, followed by the higher, followed by the higher. You see? So liquids get collected according to difference in boiling points, so that the lower boiling point liquid is collected first, followed by the higher and the highest one. Now we have a very interesting method of separation in this chapter, which is the chromatography. Now in chromatography, we separate substances in a mixture according to their solubility. The most soluble substance will be carried for a larger distance away from the atom line by the solvent, followed by the less soluble one, and so on. So the most soluble substance is carried to a larger distance away from the atom line, followed by the less soluble and the least. The least soluble one, which might be in some cases insoluble, will stay on the atom line without being resolved by the solution or by the solvent we are using. So it won't give any spots above the atom line. It will remain on the atom line, showing that it's insoluble in that solvent. Again, the most soluble substance would have the highest RF value. RF value is the ratio between distance traveled by the spot and distance traveled by the solvent. So if you have a chromatogram drawn for you and solvent front is indicated on that chromatogram, you have the spot here, for example, for substance X. Then to calculate its RF value, you will simply find distance X and distance Y and divide X by Y. So the RF value here will be X over Y. RF value is forever, a value which is less than 1. Forever, it's less than 1. Okay? Now proceeding to the next chapter. Chapter 3, atomic structure, is one of the most important chapters. You have to be able to differentiate between an electron, a proton, and a neutron. These are subatomic particles. You have to be able to write the electron configuration of different elements in the periodic table from element 1, proton number 1, to element proton number 20, which is calcium. You must be able to differentiate between metals and non-metals. Metals have 1, 2, or 3 electrons in outer shell. Non-metals have more than 3 electrons in outer shell. And you must be able to draw ionic compounds showing valency electrons in the form of circle diagrams that we call sometimes dot cross diagrams, showing the positive and the negative ion. For example, if we have the ionic compound sodium chloride, this is the sodium ion. Your examiner will show you maybe the first shell, and he will leave you to draw the second electrons in the second shell and those in the third one. طبعا there shouldn't be any electrons in the third one because that electron has been lost during the reaction taking place. Now sodium will have a positive 1 charge combined with chlorine, proton number 17, which has to gain 1 electron from the sodium during this reaction to form the chloride ion. So this is how sodium chloride is drawn. Maybe he will give different symbols for the electrons on the chloride ion to make it different than those on the sodium ion, most probably. So let's put them in circles, except one of them, which should be an X. That one that came from the sodium. So that's how it should look like. Also, you have to be able to draw the covalent molecules. Hydrazine is one of the famous compounds he has been asking about in the latest exam papers. This is hydrazine. Drawing hydrazine as a dot cross diagram is not that difficult. We will be learning it in the coming session, inshallah, or in the coming video. Let's wait for a few seconds. Now for hydrazine, if I want to draw it as a dot cross diagram showing that nitrogen electrons are X and the hydrogen electrons are dots. So if I will draw it, it will look like that. Based on the fact that nitrogen as a group 5 element should share 3 electrons, and it will have 2 unshared electrons in outer shell as it has 5 electrons in total, and the hydrogen has only 1 electron to share, so it will be sharing it. Then we'll come to the giant structures. We have giant ionic lattice, we have giant metallic lattice, we have giant covalent molecular structures, which are diamond and graphite. And don't forget the family for diamond, which are silicon, germanium, silicon dioxide, germanium dioxide. These are the giant structures you should be learning. طبعا ionic compounds have giant lattices where negative and positive ions are arranged in a certain pattern, and strong electrostatic attraction forces exist between these ions, making ionic compounds appear as solids at room temperature, having a high melting and a high boiling point, and they conduct electricity only in the molten or solution form because of having free moving ions in these states. Metallic structure have regularly arranged positive ions of the metal with a sea of free moving electrons around it. Metal ions can slide over each other. The layers can slide over each other when forces applied. Metals can form alloys which are good conductors of electricity as well due to the free electrons present in their structures. Metals are good conductors of heat, and they exist as solids with high melting and high boiling points due to the strong electrostatic attraction forces between the free moving electrons and the positive ions of the metal. Giant covalent structures like diamond have carbon atoms bonded to each other by strong covalent bonds. Each carbon is bonded to 4 other carbons in a tetrahedral structure, making the melting and boiling point of diamond so high and its strength is so strong. Diamond is so hard that we use it in drillers and in jewelry because of its crystalline, shiny appearance. In graphite, carbon atoms are bonded together in hexagons, which are appearing in parallel layers. The carbon atoms in graphite are bonded to 3 other carbons with strong covalent bonds, but layers in graphite can easily slide due to the weak van der Waals forces holding them, and that's why graphite is used as a lubricant and is soft. Graphite has free moving electrons, 1 unshared electron per each carbon that is ready to carry and conduct electricity. Now moving to the next chapter, which is the mole calculations. This is chapter 4. We have the 7 rules that we should be memorizing to use during solving problems. And don't forget the fact that you will use the molar ratio to calculate the number of moles of any substance that you don't have any data provided to you in the problem, and you want to find its number of moles. يبقى moles of any substance with no clear or complete numerical data can be calculated by the molar ratio. For example, if I write this equation for you and I ask you for the molar ratio between hydrochloric acid and zinc, you will say that molar ratio here is 1 to 2. The zinc ratio with HCl is 1 to 2. HCl ratio with hydrogen gas is 2 to 1. You see, that's what I mean by molar ratio. In this chapter, you have to be aware of writing chemical formula in the correct way. For example, ammonium phosphate you should be aware that ammonium ion is NH4, phosphate ion is PO4. Valency of ammonium ion is 1, valency of phosphate ion is 3. You switch valences and then you write the formula as NH4 by 3 PO4. This is the correct formula for ammonium phosphate. In this chapter, you should be able to balance equations in the correct way. If you have an equation that looks that this is the thermal decomposition of aluminum nitrate by heating into aluminum oxide, nitrogen dioxide, and oxygen. Now for the first while, you will tell me, teacher, let's put 2 beyond or before aluminum nitrate. And then if you do this, nitrogen will come to be 6, you see? And then oxygen, 3 by 3 is 9. 9 times 2 will be 18 oxygens. Here you have 2 oxygens plus 12. This is totally 18. So to make it 19, put half here. Is it acceptable, teacher, that we balance the O2 in an equation by a fraction? Yes, it's acceptable. And it will be totally correct. You can do this, or you can multiply the whole equation by 2 so that to make it a whole number. So if you multiply it, all of it by 2, it will be 4 aluminum nitrates decomposing into 2 aluminum oxides. I'm sorry, this is 3. It's 15. I'm sorry, this is 15. And this is 1.5. Okay, so still it's a fraction. So if you have this equation and you don't want to leave the oxygen balanced with a fraction, simply multiply it all by 2. So you will have 4 aluminum nitrates and 2 aluminum oxides and 12 nitrogen dioxide and 3 oxygen. Then that's okay. So you can leave it as a fraction or you can simply multiply it by 2. One of the equations that I found hectic for some students to balance and they got confused about it is balancing the equation of the reaction between phosphorus oxide of the type P4O10 and sodium hydroxide to form sodium phosphate and water. You have 4 phosphorus, you will put 4 here. This will make your sodium 12, so put 12 there. So your hydrogens came to be 12 hydrogens, so simply put 6 at the water. You see? Now, you will ask me about what about oxygen, teacher? Now it's balanced. Now you have here 12 oxygens plus the 10 here, so totally you have 22 oxygens. Now let's count. 4 by 4 is 16 oxygens, and you have 6 oxygens in the water, totally 22. Now it's balanced. You see? I finished the 20 boards here on Zoom. I will stop the recording for a while and start a new video. So P will be with me for a while till I do that. Now it's paused. Yes. I'll just send this to our group on WhatsApp. طبعا objectives of each chapter is to be respected. يعني إيه? I have to know what exactly my examiner wants from me as a student per chapter. So that's your main aim. Okay, so regarding the first 4 chapters, I said the main ideas. Now your rule is to solve as much questions as you can for covering these chapters, at least 2 questions for each idea that I just gave. So if you do that, خلاص, everything is fine, it's settled. You can go through the exam in a safe way and you will get, inshallah, your A star. تمام؟ يبقى the first 4 chapters are covered. I'm going to start with the next one, which is chapter 5, periodic table redox reactions, and proceed for the next 4 ones. I'm going to divide them in 4s. I'm just waiting for this video to end and then I will resume. Now, yes. Now resuming. So regarding chapter 5 is the periodic table and redox reactions. In this chapter, you are studying the properties of group 1 characteristics of group 1 metals and group 2 transition elements, group 7, and group 8. That's what you study through this chapter, plus redox reactions طبعا. Now, in this chapter, you have to know the very important and characteristic properties of group 1 that differentiate them from other groups. Now, group 1 metals are soft, can be cut easily with a knife at room temperature. They have low density, they have low melting and low boiling points. These 3 properties I just mentioned are characteristic physical properties for group 1. Now, characteristic chemical properties of group 1, they have 1 electron in outer shell and they have only 1 valency, which is +1. They cannot be used as catalysts. Now, these are 3 characteristic chemical properties for group 1. Group 1 metals, you should be aware of the reactions. They're vigorous, famous reactions with water. They're releasing the alkaline solution of the metal hydroxide and giving out hydrogen gas. The reactions with non-metals like halogens forming metal halides, which are solid compounds. All compounds or group of group 1 metals are soluble. They are all white colored. They do not form colored compounds. Forming white colored or white solids is a chemical property as well for them. Proceeding to group 2 are harder than group 1, of higher density, higher melting and boiling point, but still they are less harder than the transition elements of lower melting and boiling points than them. طبعا group 2 are less reactive than group 1 because they have to lose 2 electrons from their outer shell to react. Loss of electrons is difficult because of the attraction forces holding these outer shell electrons to the nucleus, because they are attracted to the protons, remember? So loss of 2 electrons will be much harder than loss of a single electron, like in group 1. So group 2 are less reactive than 1 because of that. Both group 1 and group 2 elements have increased reactivity as you go down the groups. Why? Because as you go down group 1 and 2, atoms get larger in size. Outermost electrons become further away from the nucleus and easier to lose. So the reactivity increases as you go down. Proceeding to the transition elements, I'm mentioning 4 characteristic chemical properties and 3 characteristic physical ones. The chemical and physical properties of transition metals shouldn't be switched when you answer questions regarding them. If the examiner asks for physical properties, you cannot just write chemical ones. No, it's not accepted. If you ask for a chemical property and you write a physical property, then you will be deduced a mark. The 3 characteristic physical properties of transition metals are being hard, of high density, high melting, and high boiling points. The characteristic chemical properties of them are forming colored compounds, can act as catalysts, they and their compounds, forming complex ions. What is a complex ion? It's an ion that consists of more than 1 element, like the manganate ion and the dichromate ions. having more than one valency or more than one oxidation state, this is a very important chemical property for transition elements. So I just mentioned their characteristic physical and chemical properties. Now, the most important transition metal ions that you should be memorizing are the chromium 3+ and 6+ ions, the cobalt 2+ and 3+, the iron 2+ and 3+, the manganese 2+, 4+ and 7+, the vanadium 2+, 3+ and 5+, and many others. Okay. Proceeding to group 7 elements, which start with fluorine and end up with astatine. طبعا these are non-metals. They have 7 electrons in outer shell and they gain electron during their reactions, forming a negative ion of the type -1. The reactivity decreases as we go down because as we go down the group, size of atoms increase. It becomes difficult for an atom to attract an extra electron in outer shell and gain it to form the negative ion, so reactivity decreases. Halogens have very characteristic properties that change or vary as in trend as you go down the group. Their color gets darker as you go down the group and they become harder as we go down. Harder. They change from a gas to a liquid to a solid. Their melting and boiling points increase as we go down the group and their densities increase as well. Group 7 have very important chemical reactions, especially those displacement ones where a more reactive halogen displaces a less reactive one in its aqueous solution, like the displacement reaction between chlorine and bromide or iodide or astatide ions. Now I'm writing here the net ionic equations for the displacement reaction of the less reactive halogens by chlorine. You see, these are the net ionic equations. These are all redox reactions. I'm going to discuss one of them and illustrate the reducing and the oxidizing agent. Now, in this reaction, chlorine has a 0 oxidation state. An uncombined element has an oxidation number of 0. Now, when it came out as -1. So it has undergone reduction. It gained electrons. And the gain of electrons here made it work as an oxidant. An oxidant or an oxidizing agent is a substance that gains electrons during reactions. Now, the bromide ions acted as a reducing agent or a reductant. Reductants usually lose electrons during reactions and they get oxidized. You see? So you can see chlorine changed its oxidation state from 0 to -1 during the reaction, and bromine changed its oxidation state from -1 to 0 during the reaction. Usually oxidation state of the reductant increases during reactions and the oxidation state of oxidant decreases during the reaction. Proceeding to chapter 6, which is the electrolysis or electrochemistry. Is the branch of chemistry that discuss effect of electric current on ionic compounds, how the split of ions happen and how ions get discharged at different electrodes. Now, electrodes used in electrolysis are two types, inert and active. طبعا in active electrolysis, you have electrodes made of any metal other than platinum. So any metal other than platinum will act as an active electrode, and it will do the process without giving any chance for the electrolyte to get involved in the reaction. So the active electrodes, which is any metal other than platinum, will do the whole process, and the electrolyte will have no role to carry out. In inert electrolysis, where electrodes are inert, everything is done by the. So let's discuss this. Now, in electrolysis, we are going to discuss active and inert electrolysis, both of them. Now, in inert electrolysis, where the electrodes used are inert, we usually use inert electrodes when we electrolyze molten ionic compounds, when we electrolyze bauxite to extract aluminum, when we electrolyze the concentrated sodium chloride or any group 1 metal halide, when we electrolyze copper sulfate aqueous solution, and when we electrolyze water and also dilute sulfuric acid. So during all these electrolyses, we use inert electrodes. In molten ionic compounds, the non-metal ion get attracted to the anode and get discharged as a gas there. The metal ions get attracted to the cathode and are discharged out there. Now, in the molten ionic compound electrolysis, we get usually the silvery deposit of the metal at the cathode and the gas at the anode. For example, if we have molten potassium iodide, then we have purple vapors of iodine released at the anode and silvery deposit of potassium metal at the cathode. In electrolysis of water, we will get two gases. Hydrogen gas released at the cathode, oxygen released at the anode, and never forget their equations, please memorize it. In electrolysis of bauxite, we get four gases at the anode and the aluminum metal at the cathode. The four gases that we get at the anode are the carbon monoxide, carbon dioxide, oxygen, and fluorine. Step 1, oxide ions get discharged at the anode by loss of electrons, forming oxygen gas. And due to the high operating temperature, which is ranging from 800 to 1000 degrees Celsius, oxygen reacts with carbon of anode, forming both carbon monoxide and carbon dioxide gases. Aluminum ions get discharged at the cathode during bauxite electrolysis, forming aluminum metal. Bauxite is aluminum oxide, and during electrolysis of bauxite, we mix it with molten cryolite so that to lower the operating temperature and increase the electroconductivity of bauxite. In the electrolysis of dilute sulfuric acid, any dilute solution usually releases hydrogen at the cathode and oxygen at the anode, and the electrolyte changes to a concentrated solution of the same chemical. During electrolysis of copper sulfate, using inert electrodes, we obtain copper metal at the cathode as a red-brown deposit and oxygen at the anode. The electrolyte blue color fades out during the process due to the formation of the colorless solution of sulfuric acid. During electrolysis of aqueous sodium chloride using inert electrodes, fluorine gas is given out at the anode, hydrogen gas is given out at the cathode, and the electrolyte changes into an aqueous solution of sodium hydroxide. Regarding the active electrolysis that you have in your syllabus, We have active electrodes used in the electrolysis of aqueous copper sulfate using copper anode and a copper cathode. Purification of metals. We have the impure metal anode, and we have the pure metal cathode, and the electrolyte will be a soluble salt of the metal solution. And in active electrodes, we have also the electroplating, where we have the object as a cathode, and we have the metal as anode. Equations, طبعا we have the equations in my revision notes. You can get my revision notes if you are not one of my students from Riviera Center. It's there already and you can get it from them. Regarding the next chapter, but before going to the next chapter, I remembered something. Now, during electrolysis, we observe that oxidation takes place at a node, where negative ions lose electrons there. And at cathode, reduction takes place, where positive ions gain electrons there. So accordingly, I can consider negative ions as our reducing agents. Remember, reductants lose electrons during reactions. Reductants lose electrons during reactions. And we can consider positive ions as oxidants, where oxidants usually gain electrons during reactions. Going to the next chapter, which is a very important one, chapter 7, acids, bases, and salts. I, as a teacher, advise you to memorize formula of acids and their names, formula of bases, formula of oxides, and the tables of anions and cations, table of tests for gases, and table for collection of gases as well. Now, as we agree, your examiner wants some skills to be very well learned by you. You have to show that you are capable of showing your skills in chemistry as he wants. So what he wants from you in that chapter is to be able to identify the term acid, to be able to define the term base, to be able to determine the pH value of weak acids, weak bases, strong acids, strong bases. You have to learn by heart the different colors of the universal indicator at different pH values. You have to be aware of the color of the indicators used in titration reactions, like litmus solution, which is red in acidic medium, blue in alkaline medium, purple in neutral medium, methyl orange, yellow in alkaline medium, red in acidic medium, orange in neutral medium, and the phenolphthalein, which is purple in alkaline medium, colorless in acidic and neutral medium. Your examiner wants you to be able to prepare salts, show how to prepare salts. And different salts that we have in the syllabus are three categories. The soluble salts, which are either group 1 and ammonium salts or other soluble salts. Group 1 and ammonium salts are prepared by titration method. Other soluble salts are prepared by the excess method, adding excess of the metal to the acid or excess of the metal oxide, metal hydroxide, metal carbonate, metal bicarbonate to the acid solution. and then filter to remove the excess unreacted substance, and then heat filter it to crystallization point, cool, filter to obtain the crystals and dry them between filter papers. You should be able to describe the titration experiment. I predict that tomorrow you will have a titration experiment in your exam paper 4. Be ready for that. How do we describe titration to obtain crystals of ammonium sulfate, for example? Fill a burette to the 0.0 centimeter cube mark with dilute sulfuric acid solution, pipette 25 centimeter cubes of ammonium hydroxide in a conical flask, add few drops of methyl orange indicator, flask will turn yellow, contents of the flask will turn yellow, start adding the acid till color gets orange, record volume of acid added, repeat the same experiment using same volume of acid and alkali but without the indicator, heat solution to crystallization point, cool, filter to obtain the crystals and dry them between filter papers. That's how to prepare crystals of ammonium sulfate. So titration is quite important. I have chosen methyl orange as an indicator during titration of ammonium hydroxide because ammonium hydroxide is a weak alkali. Any weak substance, either an alkali or an acid, should be titrated using methyl orange indicator. For sure, we have other indicators in our labs that we teach even in A-level chemistry, but it's not in your syllabus as IG students, so I will not mention them. For any strong alkali against strong base, we are usually using phenolphthalein indicator or litmus solution indicator. And I'm going to give you an example for the preparation of crystals of sodium nitrate using phenolphthalein indicator. Now, fill a burette to the 0.0 centimeter cube mark with dilute nitric acid solution and pipette 25 centimeter cube of sodium hydroxide in a conical flask, add few drops of phenolphthalein indicator. Color of the contents of the flask will get purple. Start adding the acid solution till color changes from purple to colorless, record volume of acid added. Then repeat the experiment using same volume of alkali and the same volume of recorded acid solution, but without the indicator. Stir and then heat to crystallization point, cool, filter to obtain the crystals and dry them between filter papers. Preparation of an insoluble salt, such as lead bromide, is done by mixing two solutions. Each one contains one of the ions required here, lead and bromide ions. By mixing equal volumes of equal concentrations for lead nitrate and potassium bromide, equal volumes but different concentrations, I'm sorry, because of the molar ratio. Lead nitrate reacts with potassium bromide in a ratio of 1:2. I'm repeating again. By mixing equal volumes of potassium bromide and lead nitrate aqueous solutions but different concentrations, or the opposite, equal concentrations but different volumes, so that one of the two variables will follow the ratio between them, which is 1:2. Then we'll wait till no more precipitate of lead bromide forms. Then we filter to obtain the precipitate as a residue on the filter paper, and we wash it with distilled water to remove soluble impurities. Make sure that you write the term soluble impurities so that to gain the mark. Why do we use distilled water to wash the precipitate? To remove soluble impurities, okay? Now, preparation of any insoluble salt is done by mixing two solutions. Each one contains one of the ions required for preparation of that insoluble salt. For the preparation of soluble salts like nickel sulfate, for example, we use excess amount of nickel carbonate with 50 centimeter cube of dilute nitric acid solution. By adding nickel carbonate to the dilute nitric acid if we are preparing crystals of nickel nitrate, but if it is sulfate, we'll use sulfuric acid. So name of the acid depends on the name of the salt we are preparing. And then we wait until no more bubbles are observed for carbon dioxide gas, or no more loss in mass, which is more accurate than observing bubbles, happens because loss of mass will take place due to the escape of carbon dioxide gas during the reaction. So usually we do such a reaction on a digital balance. in a beaker, which is put on a digital balance so that to observe the mass loss. When no more mass loss is taking place, then reaction is finished. Then we'll filter to separate the insoluble excess amount of nickel carbonate, and then we will heat filter it to crystallization point. We will cool filter to obtain the crystals and dry them between filter papers. Types of oxides that you should learn by heart in this chapter are 4 types: basic oxides, amphoteric, acidic, and neutral. Basic oxides are those oxides that react only with acids, but they do not react with alkalis because they have basic characters, such as sodium oxide, iron oxide, and copper oxide. Amphoteric oxides like aluminum oxide and zinc oxide are those oxides that have both basic and acidic properties, and they can react with both acids and alkalis at the same time. Neutral oxides like carbon monoxide, nitrogen monoxide, and water are those oxides with no acidic or basic characters, and they can never react with either acids or alkalis. Acidic oxides such as phosphorus oxides, P2O3, P2O5, P4O6, P4O10, sulfur dioxide and sulfur trioxide, nitrogen dioxide, and carbon dioxide, silicon dioxide. Now, silicon dioxide is acidic, and we have found that silicon dioxide is capable of reacting with concentrated hot sodium hydroxide to form sodium silicate, which is the salt here. This shows that the silicon dioxide, which is sand, actually is acidic. An acidic oxide is capable of reacting with alkalis, but they do not react with acids. The actions of cations and anions, طبعا you have to memorize the tables of these reactions and the color of precipitates obtained by these ions, and the test for gases as well. Proceeding to chapter 8, I didn't write anything for chapter 7, yes, because it's mostly memorization. It's full of informations that you should memorize. Information of chapter 7 are all facts actually, and when we have facts, then we have to memorize. Chapter 8 is the same thing, facts. But applications are done or are found in our syllabus in chapter 2, chapter 3, chapter 4, chapter 5, and chapter 6. Redox reactions, electrolysis, mole calculations, experimental techniques, separation methods, atomic structure. All these have ideas to apply, so you have less memorization in those chapters. But in here, chapter 7 and 8, they are full of memorizable information. Now, chapter 8 talks about metal extraction. We have the 2 famous metals that we extract during this chapter, which is iron and zinc. Don't forget the equations, and that long essay questions can come, and I expect one of them tomorrow. In your old syllabus, you have 4 processes, 6 processes in which essay questions come. What are they? Extraction of zinc, extraction of iron, extraction of aluminum by electrolysis of bauxite, the Haber process, the contact process, and electrolysis of concentrated aqueous sodium chloride. Again, I am listing 6 essay question issues or topics in your syllabus. One of them will come tomorrow, inshallah, in your exam paper 4. I'm going to list them here on the board for you. What are they? يبقى ideas of essay questions, contact process, which is manufacture of sulfuric acid, Haber process, extraction of iron, extraction of zinc, extraction of aluminum by electrolysis of bauxite, and electrolysis of concentrated sodium chloride. These are the 6 essay questions that you might face in tomorrow's paper, inshallah. Okay? Now, going back to the extraction of iron and zinc, you have to be aware that you in iron, you have 5 equations during its extraction, which is combustion of carbon or coke to form carbon dioxide, formation of the reducing agent by reaction of coke with carbon dioxide to form carbon monoxide, reduction of hematite by this reductant, to form molten iron and carbon dioxide, decomposition of calcium carbonate, which is limestone, at the high temperature of the furnace into calcium oxide, carbon dioxide gas, reaction of calcium oxide with the sandy acidic impurities present to form slag, which is calcium silicate. Extraction of zinc is much similar to that, is so similar to that of iron, except that the starting step is the roasting of zinc blend, which is strong heating in oxygen, to turn it into zinc oxide and sulfur dioxide gas. Then extraction of zinc by reduction with carbon to its oxide. Again, extraction of zinc by reduction of its oxide with carbon or with carbon monoxide. To give zinc and carbon dioxide or zinc and carbon monoxide. So any of these equations will be accepted. During this chapter, you should be able to answer questions regarding recycling of metals. Recycling of metals have advantages and disadvantages that you should learn. Reminding you of them, advantages are saving energy and conserving natural resources of metals and solving the problem of waste disposal. Disadvantages is that sometimes it's not cost effective on the long term, and the objects made of recycled metals are not as durable as those made of pure ones. In this chapter, we should discuss the corrosion and rusting, and you have to be able to differentiate between them. Corrosion is the reaction of the metal surface with oxygen of air, forming a layer of the metal oxide. And corrosion can happen to any metal except iron. We describe corrosion of iron as rusting. Rusting is reaction of iron with oxygen and water to form the flaky solid iron oxide. We lose a very important metal by this method or by this process. So we have to prevent the rusting by 7 methods, which are galvanization, coating with zinc, greasing, coating with a layer of grease, painting, coating with a layer of paint, coating with a polymer, which is a plastic sheet, electroplating, which is electroplating the surface of iron with a metal that resists corrosion, like gold, platinum, silver, or copper. And finally, we have the 2 famous processes, cathodic protection and sacrificial protection. In cathodic protection, we connect the surface of steel to the cathode of a power station so that to supply electrons to the surface, and these electrons will prevent iron from losing its own electrons and from oxidation and rusting. During sacrificial protection, we put blocks of a metal which is more reactive than iron on some certain distances away from each other so that to release electrons, these blocks of this reactive metal will corrode instead of iron, releasing electrons to the surface. During corrosion, the metal gets oxidized and losing its own electrons to the surface of iron will cause iron to remain unoxidized, and this will prevent the rusting of iron. A very important example for the cathodic protection used in our life is the protection of ship hulls by fixing blocks of zinc around it down there so that to prevent rusting in seawater. Remember that seawater contains a lot of ions and salts which enhance the method of rusting. We have to protect the iron of these ships by putting a more reactive element like zinc blocks. Motors of ships are protected against rusting by greasing. And remember, when you swim in the sea, sometimes you find some grease floating at the surface of water, showing that a ship was passing by. Greasing, galvanization, painting, coating with a polymer, and even electroplating. All these methods depend on one idea, which is isolating the surface of iron from any contact with air. Only one of these methods, even after the surface is scratched and iron beneath is exposed, still iron beneath doesn't rust. Why is that? Because of the formation of a layer of zinc oxide. That's the galvanization method. In galvanization is done by coating iron with a layer of zinc. Zinc is more reactive than iron. Even if the layer of zinc is removed and iron is exposed, still iron doesn't rust because zinc is more reactive, it will corrode instead of iron. Releasing electrons to the surface by oxidation of zinc will cause this iron not to rust as it is already saturated with electrons. So it won't be able to lose any of its own electrons. Proceeding to the next chapter, which is chapter 9. Sometimes some students face problems with this chapter solving its problems, which are calculation of energy changes. Now, for example, if we have a reaction like reaction between hydrogen and nitrogen to produce ammonia, now, simply to calculate delta H or the energy change during this reaction, we should split our reaction into two areas. Reactant area where bond breaking happens and the product part where bond formation takes place. Now, in bond breaking here, we have 3 bonds for hydrogen. So I will multiply 3 to the hydrogen-hydrogen bond energy value. And we have 1 nitrogen, triple bond nitrogen. So I will multiply the bond energy value for nitrogen, triple bond nitrogen by 1. Then I will get the total here for bond breaking. And for bond formation, actually in this reaction, I have 6 bonds because these are 3 bonds times 2, yani 6 NH bonds. So I will simply multiply 6 by the bond energy value for the NH bond. Then I will get the total also here. And then simply I will do subtraction. Subtract them to get delta H, which is the energy change. So total of bond breaking minus total of bond formation. And the subtraction product here, if it is positive, then reaction is endothermic. If it is negative, then reaction is exothermic. To comment on the reaction, if your delta H is negative, then reaction is exothermic because energy used during bond breaking was less than energy released during bond formation. If delta H obtained was positive, then reaction is endothermic, and this means energy used during bond breaking was much larger than energy used during bond breaking was much larger than energy released during bond formation. I'm going to repeat this point again. If delta H obtained was negative, then reaction is exothermic, and the energy used during bond breaking was less than energy given out during bond formation. If delta H obtained was positive, then reaction is endothermic, and this means that energy used during bond breaking was larger than energy given out during bond formation. In chapter 9, you have to be aware of the definition of the term fuel, fossil fuel. A fuel is a substance that ignites to release heat energy. A fossil fuel was a remaining of a dead organism that have fossilized over millions of years. Examples of fossil fuels: solid coal, liquid petroleum, and the gaseous natural gas. Hydrogen as a fuel has some disadvantages, which are not safe to store or transport, expensive to obtain by electrolysis of water, doesn't have a distribution network. Advantages for using hydrogen as a fuel: it's easily ignited, releasing big amount of heat energy obtained from a renewable source of energy, which is water. So these are advantages. Going to chapter 10, which is the rate of reaction and equilibrium. طبعا rate is affected by 6 factors. Now, factors affecting rate of a reaction are temperature, pressure, a catalyst, surface area, concentration, light. So we will be discussing each point separately. We will be discussing each point separately. Temperature. When temperature is increased, particles gain more kinetic energy and move faster. They collide more frequently to give more effective frequent collisions, so rate of reaction increases. That's for temperature. If you are asked to describe the effect of temperature using the particle kinetic theory, then you should say what I just said. Regarding the effect of a catalyst reduces or decreases activation energy by providing an alternative pathway for the reaction. A catalyst increases rate of reaction by increasing the number of frequent effective collisions by reacting particles and giving the product in less time. A catalyst increases rate of forward and backward reactions on an irreversible reaction equally and doesn't affect position of equilibrium. Temperature affects rate of both forward and backward reactions equally, but it does affect position of equilibrium and affects yield of product according to the type of reaction, and we will be discussing this point later on. Effect of the surface area: if we have a solid reactant and we use a powder of that reactant, powders have larger surface area, particles will be more colliding frequently and give more effective frequent collisions. More number of particles will be in the reaction medium and rate of reaction will increase. Effect of pressure: if we increase pressure by removing the reaction mixture from its container to a smaller size container. Increasing pressure on the reaction mixture is done by having a much deeper solution. The increased depth and the big height will increase the pressure exerted on the reacting particles, making them collide on a much faster way and giving the product in less time. Like when we react 100 centimeter cubes of both solutions together in a large container and in a smaller one. In a small container, depth of the solution will be greater and pressure will be more, so rate of reaction will be greater. So usually pressure is greater in a smaller size container than in a larger one. Effect of concentration: a concentration will affect rate of reaction and yield of product as well if this concentration was changed for the limiting reagent. So if I increase concentration of the limiting reagent, both rate and amount of product will increase. But if I change the concentration of the excess reagent, only rate is affected. Effect of light طبعا on photochemical reactions like photosynthesis or photographic films. When we use light to observe the rate at which film gets darker by reduction of silver ions due to the light that gives energy to the electron on the bromide, ion in silver bromide, causing this electron to transfer to the silver ions, causing it to get reduced to silver metal, and a gray-black deposit appears on the film of the camera. So we discussed the effect of concentration, temperature, catalyst, the surface area, the light, and the pressure. What about equilibrium? Now, equilibrium is one of the very important topics, and I expect a good question to come tomorrow, inshallah, in paper 4. Now look at this reaction, please. Now, this reaction is a reaction between carbon monoxide and hydrogen to obtain methanol. Reaction is exothermic, releasing great amount of heat energy that methanol comes out as a gas. You can see that number of moles of reactants are 3, and number of moles of products is 1. So if I increase the pressure, then equilibrium will shift more to the right, to the side of less number of moles. Yield of methanol will increase. If I decrease pressure, yield of methanol will decrease. At high temperature, equilibrium will shift to the left side and amount of methanol obtained will decrease. Temperature will affect yield of the product if my reaction is reversible. Pressure as well will do the same thing. But both temperature and pressure will increase rate of reaction. Now, you have to be able to separate the effect on the yield from that on the rate. Rate has a different issue. It's a different idea. Now, effect on the rate is very clear. If you increase pressure or temperature, rate will increase for either forward or backward reactions. But effect of temperature will depend on whether your forward reaction is exothermic or endothermic. Now, in this case, we have an exothermic reaction. So if we increase temperature over a certain limit, then reaction will shift simply to the position of equilibrium, will shift simply to the left side. And the amount of reactants will increase, amount of products will decrease. And we don't want this. So we have to use a compromised temperature so that to ensure we get a good amount of the product at a good rate. This compromised temperature depends on your reaction. Now, for example, the compromised temperature for the reaction of hydrogen with nitrogen to obtain ammonia is ranging from 300 to 550. Above 550, yield of ammonia will decrease. For the contact process, the compromised temperature used is 450. If we exceed this temperature, then yield of sulfur trioxide gas will decrease. So you have to be able to differentiate between effect on position of equilibrium and effect on the rate. Regarding chapter 11, which is air and water, it's full of information that you should memorize: percentage of gases, gases that cause air pollution, and the effect of these pollutants on human health and on environment, how to avoid the release of these pollutants. One of the very important issues in that chapter is the catalytic converter and its role in decreasing the release of toxic gases to the atmosphere. Now remember, the catalytic converter is capable of turning toxic gases into less toxic ones. These are the unburned hydrocarbons that turn into carbon dioxide and water vapor by the converter. Carbon monoxide that turns into carbon dioxide. Nitrogen monoxide and nitrogen dioxide that both turn into nitrogen gas. So the converter basically change or turn the toxic gases into less toxic ones. In that chapter also, you should be able to describe the formation of acid rain by dissolving nitrogen dioxide and sulfur dioxide in rainwater, forming acid rain that have 4 bad effects: killing plants and cause deforestation due to turning the soil acidic, killing marine life by turning the water acidic. This corrosion or erosion of buildings due to the reaction with limestone, that is one of the basic materials in construction materials. And also corrosion of metallic structures in streets is so increased by acid rain. Remember, carbon monoxide gas is released to the atmosphere by incomplete combustion of fossil fuels. Sulfur dioxide is released by burning fossil fuels containing sulfur. Oxides of nitrogen are released due to the high temperature of car engines. Oxygen of air combines with nitrogen of air, forming oxides of nitrogen. And don't forget the fact that oxygen exists in air as 21%. So whenever you are asked to calculate the amount of oxygen in a certain volume of air, remember this information. Oxygen exists as 21% of the total air volume. Nitrogen exists as 78% of the total air volume. Argon exists as 0.9% of the total air volume. Okay. Now, in that chapter, you have to be aware of the steps used to purify water. طبعا water treatment is very important to obtain drinking water, and it's essentially done in two main steps, filtration and chlorination. Filtration is done by passing water through coarse sand filter and fine sand filter, and chlorination is done to kill bacteria and remove microbes. And then we add fluoride ions to the water so that to decrease the rate of tooth decay. We have to add some sulfur dioxide gas to the water as a preservative and killing bacteria, and also to remove any excess amount of chlorine gas present in water. Don't forget that testing for pure water is done by measuring its boiling point 100 degrees Celsius or freezing point 0 degrees Celsius. And chemical tests do not ensure water purity by using anhydrous copper sulfate or anhydrous cobalt chloride. This will lead us to the next chapter, which is sulfur and carbonates, and then the organic chemistry finally. Now, sulfur and carbonates, some objectives are needed for these chapters. In sulfur, contact process is one of the most important things you have to learn in that chapter, and the reducing power of sulfur dioxide and the ability of sulfur dioxide to form sulfurous acid by dissolving in rainwater. Sulfurous acid is a very strong reducing agent. Both sulfur dioxide and its sulfide salts and its acid, sulfurous acid, the three of them are capable of turning the color of potassium manganate 7 from purple to colorless and dichromate 6 from orange to green. The contact process has some equations that you should memorize by heart, which is burning sulfur in oxygen to obtain sulfur dioxide, and then reacting sulfur dioxide with more oxygen to obtain sulfur trioxide. And this is the reversible reaction that we have in this process. And then dissolving sulfur trioxide in concentrated sulfuric acid to get oleum, which is diluted by the correct amounts of water to obtain sulfuric acid. Now, in the carbonates, you should be aware of the Carbonates cycle. What is it? Now remember, limestone, which is named as chalk, sometimes named as marble or calcium carbonate, decomposes by heating into lime and carbon dioxide gas. And then lime turns into slaked lime, which is solid calcium hydroxide, by adding little amount of water. And then slaked lime turns into lime water by adding more amount of water. Then lime water will turn into calcium carbonate by passing carbon dioxide gas through it. You should be aware also of the fact that excess amount of carbon dioxide gas bubbled through turbid lime water will turn it into a clear solution and remove that turbidity due to the formation of the soluble substance calcium hydrogen carbonate. Okay, I have reached to board number 20. I'm going to pause the recording for a while and get back again. So back again, this is one of the questions that one of the students faced in paper 4. Complex carbohydrates are natural condensation polymers. They can be broken down into colorless monomers, which can then be separated and identified. X is a complex carbohydrate. Starting with a sample of X, describe how to produce, separate, detect, and identify the monomers which make it up. Your answer should include the name of the process used to break down X into its monomers, 2 types of substance that can be used to break down X, the name of the process used to separate the monomers, the method used to detect the monomers after they have been separated, and the method used to identify the monomers after they have been separated and detected. Number 1, name the process used to break down X into its monomers. Now, X is a complex carbohydrate. It should be broken down by hydrolysis reaction. Hydrolysis reaction will break down the polymer into its monomers. The 2 types of substances that can be used to break down X are either dilute hydrochloric acid solution or dilute sodium hydroxide solution, which are strong acids and strong alkalis. Then we can separate the monomers by the chromatography method. And during chromatography, the colorless spots of the sugars obtained by the complex carbohydrates will be detected by using a locating agent. A locating agent is a substance that we use to spray the chromatogram so that to give colors to the spots of the monomers obtained. And then we can identify those monomers by measuring their RF values and comparing these RF values to the database that we have for sugars, and then identify these sugars. I'm going to repeat again this. The name of the process used to break down X is called the hydrolysis process. This hydrolysis process is done to break any polymer into its monomers. The 2 types of substances that can be used to break down X are strong acids and alkalis like dilute hydrochloric acid or dilute sodium hydroxide aqueous solutions. The name of the process used to separate the monomers will be chromatography. And we can detect the monomers by spraying the chromatogram by a locating agent to give colors to their colorless spots. To identify the sugars, we use the RF values. We measure RF value by dividing the distance traveled by the spot over distance traveled by the solvent. And the RF value will be compared to that obtained for some substances we have in database, and we can identify the sugars by this method. That was the answer for this question, and I'm going to go back to the whiteboard so that to resume the revision process. So I was talking about the carbonates, and طبعا the most famous carbonate is the calcium carbonate. It has many uses, it and lime and slaked lime. Limestone is calcium carbonate, slaked lime is solid calcium hydroxide, and lime is solid calcium oxide. Now, the 3 of them are white solids. They are basic substances. We use them to neutralize acidic waste products, and we use them to neutralize acidic soil and acidic water. The best one for the neutralization of soil is calcium carbonate because it's cheap and available, and excess of it will not turn the soil alkaline. Now, proceeding to the most important chapter in all our syllabus, which is organic chemistry. And organic chemistry has 5 homologous series that you're going to learn, which are alkanes, saturated hydrocarbons, alkenes, unsaturated hydrocarbons, alcohols, carboxylic acids, and esters. Now, alkanes have the general formula CnH2n plus 2. I'm going to give a brief hint about each homologous series. One of the alkanes that we know is pentane and propane. I'm going to give pentane as an example, for a good reason that I will keep for myself. I'm going to show you how to make isomers of this alkane. Now, this is one of the isomers of it. Another one is the this one. All of them have the chemical formula or the molecular formula C5H12, but they have different structural formula. That's why they are isomers. طبعا the least boiling point one is the most branched one. This one has the least boiling point. The highest boiling point is the straight chain isomer, which is normal pentane. As I said, all of them are C5H12. Alkanes react by substitution reaction with halogens. So for example, if I have propane reacting with chlorine, I will obtain chloropropane and HCl. Proceeding to the alkenes with the general formula CnH2n, they are unsaturated with a carbon-carbon double bond as a functional group. I will give butene as an example, C4H8. It has 3 isomers, but1-ene, but2-ene, and methylpropene. All of them are C4H8. Now, alkenes react by addition reactions with hydrogen, halogens, hydrogen halides, and steam. With hydrogen using as a catalyst 150, with hydrogen using nickel as a catalyst and 150 degrees Celsius, we will obtain the corresponding alkane. So the unsaturated molecule is turned into a saturated one by reaction with hydrogen. By reaction with halogens, we will obtain the halogen substituted, the halogenoalkane, I'm sorry. Now to draw this halogenoalkane, it should be drawn in this form. It's 1,2-dichloropropane. Again, it's 1,2-dichloropropane. Reaction with the hydrogen bromide will give rise to either 1-bromopropane or 2-bromopropane. It's this or that. Or one or two bromopropane, 1 or 2 bromopropane. Reaction with steam will give either propan 1-ol or propan 2-ol. Okay. Proceeding to the addition polymerization, which is related to alkenes as it happens by opening the double bond. Now focus, please. If you have such a compound, and we want to draw the polymer chain showing 2 repeat units, step 1, put the carbon-carbon double bond as a single bond. Step 2, put attachments as they are without any change. Step 3, repeat what you did again to draw the second repeat unit. Step 4, put continuation bonds to the right and to the left. By this, you have drawn a 2 repeat unit polymer chain from this monomer. And you will name it according to the name of the monomer that you have. You will put the term poly and the name of the monomer between brackets. If we want to do the opposite thing. If you have a polymer chain and you want the monomer one, the monomer molecule, so if you have this polymer chain, then to write the monomer, just cut out a unit which is repeated, put it down with a double bond between the carbons, cancel the continuation bonds to the right and to the left, then you have your monomer molecule. Again, if you want to draw the monomer out of the polymer chain, just pick out a unit which is repeated along the polymer chain. One minute, please. I'm going to pause the recording for a while. So that's how we obtain the monomer out of the polymer chain. طبعا, I found that your examiner in the latest papers have focused on the uses and the formula of some famous addition polymers like polytetrafluoroethene and polypropene and polyvinyl chloride. So I want you to revise this part from my notes and revise the uses of these polymers. Proceeding to the next homologous series, which is alcohols. General formula of alcohols is CN H2N plus 1 OH. They are all liquids. طبعا alcohols are good fuels, especially ethanol. And the first member is methanol, then ethanol, propanol, and isomers start with propanol, propan 1-ol, propan 2-ol. By changing position of the functional group, we obtain isomers. Alcohols are oxidized into the carboxylic acids either by a strong oxidant such as acidified potassium manganate 7 or acidified potassium dichromate 6. And I found that in the latest papers, your examiner have asked about the condition needed for the oxidation to take place. Oxidation of alcohols or any substance using either potassium manganate 7 or potassium dichromate 6 is done in acidic medium. This is the condition. Another question I found is that condition required for esterification reaction, which is heating with concentrated sulfuric acid. If you just mention sulfuric acid, then you will lose the mark. He wants to see the term concentrated. Okay, remember that concentrated sulfuric acid is a good dehydrating agent. It helps removal of water so that to obtain the ester. Now proceeding to the carboxylic acids with the general formula. CnH2n plus 1 COOH. They are weak acids. And they have the same reactions that normal acids undergo, but at a slower rate. They are non-flammable. They react by a very specific reaction with alcohols, which is called the esterification reaction to form ester and water. Look at this reaction, please. This is the reaction between propanoic acid and ethanol. Again, this is the reaction between propanoic acid and ethanol. Carefully observe what will happen here. Removal of water will take place by this way. In presence of concentrated sulfuric acid and heating, water is removed to form the ester, which is ethyl propanoate. Again, our ester is ethyl propanoate. This is the ester. Then proceeding to the next and final category in the organic chemistry, which is the polymers, condensation polymers to be specific. Now, condensation polymers like starch, Styrene, nylon, and protein Now let's draw all of them. Starting with starch, which is a complex carbohydrate. It is drawn in this way. Protein, which is a polypeptide, drawn in this way. Nylon, it's a synthetic polypeptide, but protein is a natural one. There is a difference between them. Nylon has different monomers, which is diacid diamine, but protein has different monomers, which are amino acids. And finally, we have Styrene. جت على ده يعني الله. Finally, we have Styrene, which is a synthetic polyester. It is drawn in this way. So you have to memorize the formula, you have to memorize their uses. Starch طبعا is a basic substance in many plants, and we find it specifically in rice and wheat. Protein is an essential substance for growth of animals and plants, and it's naturally existing. Nylon is a synthetic polyamide, which we use for packaging, making some fishing nets and some threads that we use in surgery. Styrene is a polyester that we use in textile industries. That's chemistry 0620 in brief, and I wish you all the best in tomorrow's exam. If you have any doubts, you can ask me through the messages on WhatsApp if you have my number. If you don't have my number, you can message me on Messenger. I have a new account and I have a new page which is named after my name, Maiam Afdal. You can find my page link on my account on Facebook. I have also a YouTube channel that you can find these videos on it, inshallah. And this video I'm going to upload to the YouTube, inshallah, tonight. Thank you so much, and see you, inshallah, after tomorrow, after your session. I'm going to pause the recording for now.